Hello, everyone. My name is Samia Ashraf. I'm a Flutter GDE, a Google developer expert, a woman tech maker ambassador, and also an organizer at GDG Dubai and Flutter Abu Dhabi and Dubai. And today I am going to talk about a very interesting and a very important topic in Flutter called testing. So, even if you're a beginner, I'm sure you've heard of the word testing. So, in this session, I'm going to share some key concepts that have helped me in to perform the testing in Flutter. So, I hope to convert this into a series where this is our first session, and in the coming sessions, we can dive in deeper. So, this is more on the introductory side today. So let's begin with our agenda. Now, we're going to start with the testing overview, followed by types of testing, where we're going to discuss about unit testing, widget testing, and integration testing with an example for each. And we will also see a code example where we are going to write tests for unit, widget, and integration. So I'm keeping it very simple for this session. Now, let's have a quick overview on testing. Now, testing is a very crucial aspect of the development process. So, if you've ever um, studied the steps of software lifecycle, development lifecycle, you will be knowing that testing is one of the phases. That is because testing is what decides if your app is going to be reliable and also in smooth running in process. So it ensures the reliability and the correctness of your application. That's the reason testing is very crucial. It can sometimes what happens is if we do not test an app, especially with the large scale apps, there are more chances that the app can break. So before the rolling out of application, it's very important to test. So Flutter provides a comprehensive testing framework where you can write the tests, which is unit, widget, and integration tests in the Flutter same app itself. So there is a testing framework using which you can, in the same application, you can write the tests for unit, widget, and integration. You don't have to do it separately. It's all going to be in the same application as the same project. The more features you add to the app, the harder it gets to test manually. So, uh, when I was a beginner, so I'm just going to give you a very my scenario where when I was a beginner, I used to do manual testing. So, two types of testing, manual and automation testing. In manual testing, what we do is we are going to write the test cases, and we are not going to use any additional tools to perform the testing. We are, so let's say I'm building a very simple notes application, and I want to test that whenever I add a note, it gets saved to the list of notes or not. So what I'm going to do is I'm going to create a note, and then I'm going to go back and check my list where whether this newly created note was added or not. This is manual testing. I'm not going to write any test cases for it. I'm just going to have a scenario in my mind, and I'm going to um, manually test it out. So this is manual testing, and this can be preferred if there is if the app is very small, like more like a personal project, and if there is not enough budget for the app, then it's fine. Manual testing may be preferred that time. But if we're talking about large scale applications, then manual testing is totally not advisable. That is because you will be spending a lot of time going back and forth between the screens. Because in manual testing, when a scenario does not work out, you're going to change the code and then come back and perform the manual testing, right? So this is going to take up a lot of time, preferably also a lot of resources, because large scale applications you're going to take days to do this. So you will be spending more resources also. So in this case, what we can do is we can go and we can perform automated testing. And what does automated test mean? It is simply where you will be the type of test where you will be using tools to perform testing, and they will ensure that your app performs correctly before you publish it, while retaining your feature and bug fix velocity. So, in automation testing, because we're writing the code and performing the testing, it is quicker compared to manual testing, and it is more reliable, because the chances of human error here is very less, whereas the chances of human error in manual testing is more. And automation testing is what is reliable and preferred for large scale applications. So, a well tested app will have many unit and widget tests. It will be tracked by code coverage, that is the expected output and the test case that you write, the ratio of that. Plus, there will be enough integration tests to cover all the important use cases. So, when we talk about a large scale app or a well tested app, this app will have has gone through a lot of unit and widget tests, where every unit was properly tested and every widget was properly tested with the expected output, and also integration tests to ensure that the app will run smoothly. So unit test, widget test, and integration test can be all performed in an app to ensure that it is a well-tested app which is reliable and smooth running. This is how you can increase, or you can ensure the a better experience, a better UX experience. So these are some of the metrics. Now, we have maintenance. So for unit tests, the maintenance cost is less because we're talking about smaller units. And widget testing also, it's higher, and also integration testing. For unit testing, we will require few or no dependencies, but for widget and integration, you will require more. And the execution speed is quicker in unit and widget, because unit is basically a small portion of code, right? It is a function. So it will be quicker. Even the widget will be quicker because we're only talking about one widget. But when we talk about integration testing, it is combination of multiple widgets, so that is going to be slower to execute, especially when we write bigger, larger test cases. So now let us dive in to um, the two types of testing, which is human manual testing and automation testing. So in manual testing, human testers will manually execute the test cases without any automation tool, like we discussed. And the initial cost is lower because we do not require any automation tools, right? But as we progress, you will need more resources based on the complexity of the program. This is time consuming and also labor intensive, especially for repetitive or large scale testing. So, like we discussed, we will have to do rigorous testing in large scale applications, which is going to be very time consuming and can require more resources. And in automation testing, this involves creation of scripts that can perform predefined actions. So in automation testing, we are going to be writing different type of tests, scripts that will perform predefined actions. So we'll be writing code that is going to perform the testing for us. So in manual testing, we are going to have the scenario and we are going to execute that scenario. But in automation testing, we're simply going to write the code, and uh, we just have to write the code, and the framework is going to do the job for us. So there are three types of automation testing in Flutter. We have unit test, widget test, and integration test. So let us um, study about each of them now. In unit test, it tests a single function, a method, or even a class, basically a single unit. We do not have multiple functions, multiple methods, or multiple classes here. It's just going to be a single unit that will be tested. And the goal here is to verify the correctness of a unit of logic under a variety of conditions. So we will explore this with the help of an example. And this is also unit test is used to check if the code that we have written for a particular function is correct or not. And how are we going to do this? We are going to run the function with some input, and the output from the function is going to be um, compared with our expected output. So let's see what that looks like. Let me go back to my VS Code. So I have a very simple Flutter project here. And what this does is, here I have a counter class, a counter file that has a counter class. And what this counter class does is, it has a variable, an integer, that is initially going to hold the value 0. So basically, I'm trying to build a counter here, and I'll have two functions, the increment function and the decrement function. When I increment, it's going to increment the value by 1, and when I perform the decrement function, it's going to decrement the value, this value, by 1. So in the Flutter project, there is going to be a folder test, which is going to hold the widget underscore test.dart file by default. And this is the place where we are going to write our test cases. So this is the test case that I have written, and we're going to explore them line by line. So this function here is going to take in a description. Now, this description can be anything. We can modify it as per our convenience and as per our requirements. And there is going to be a function. And here, what I'm going to write is my test. Now, I have a very simple class called counter, and I want to test this counter class. Remember, we talked about testing single units in unit testing, and that's what I'm going to do here. And what I want to test here is, when I perform the increment function, I want to check if this value will be incremented by 1 or not. And when I want to run this decrement function, I want to check if the value will be decremented by 1 or not. So I'm going to instantiate the class and have an object here called as counter. Using this counter object, I'm going to call the increment function. Now, when I call this function, what should happen is, this value is should increase by 1, right? This function here, expect, is what we are going to verify our test result. So the first parameter here is the actual result from this test, and the second parameter that I have here is what I am going to write. So this is what I expect this test to result, to return the value. So when I run this test now, what should happen is, it's going to create the class for me. It's going to call the instantiate the class, and the object is going to call the increment function. Value will be incremented by 1. So this counter dot value will now have the value 1, and it is going to be verified against my expected value. So let's say, so now our test is passing. It passes and it says that, and it returns this description for me, indicating that the test has successfully passed. But let's build up a scenario where I am expecting something else. Let's say 2. I'm expecting a value 2, which means I'm expecting that the value um, when I call the increment function, I'm expecting the value to be incremented by 2. So that is just what I'm expecting. Now let's see what happens when I run the function, when I run the test. So here it tells me that I am expecting a value 2, but the actual return value is 1, and hence the test is failing here. So this is how we can perform unit testing in Flutter. It's this is a very simple type of testing, because you're not dealing with a lot of code. It's a single unit that we're dealing with. So yeah, so if I turn this back to, if I make it 1 again, it's going to pass because I am incrementing it only by 1. So that is our unit testing. Let's go back to our um, presentation. So here the next type of testing is called as widget testing. And as the name suggests, the a widget testing is used to test is used to test widgets. So for in other UI frameworks, this is also called as component test. And here what we do is we are going to write a widget. If you want to test one widget, then we are going to write a widget testing. So here we cannot test classes, functions, and methods. Here we are going to only test the widgets. So we can test the widgets UI, and we can even test how the widget interacts with the different elements of the in the screen. So, widget that is being tested should be able to receive and respond to user actions and events, perform layout, and instantiate child widgets. Which means if I have a screen and if I have a button in that screen, so my widget should interact with this button, and that's how we can perform testing. So, let's look at the code to get a better understanding. So again, I have a very simple code here. It's a counter widget. I have removed the boilerplate, and this is some new code called counter widget. It's a stateful widget, and what it does is it simply increments the value counter value by 1 every time I click the increment button. Now, there are two functions, increment counter and decrement counter. Again, counter value will be incremented by 1 and decremented by 1 when increment counter and decrement counter will be called. So, a very simple widget that just has a text widget and an elevated button. On on press is where the button is clicked, we will be calling the increment counter function, and where the counter value is going to be incremented by 1. So it's a very simple widget. Now let's go back to our widget underscore test.dart file, and let's write a test that is going to perform the testing, the widget testing here. Now earlier we had only the test function. Here we have the test widget, and if you just read through the information, you will get more understanding on how you can use this function. Again, I'm going to write some description. This is for my convenience, saying this is a widget test where I'm going to be testing the counter widget. And Here I'm going to let's go back to the slideshow and let's just explore the different elements here. We will get the better understanding. So widget tester is allows building and interacting with widgets in a test environment. So widget tester here, it will build and interact the widget. So when we are testing a widget also, we are going to be rendering the UI. So it's this object is what is going to build and interact with the widgets in a test environment. The test widgets function automatically creates a new widget tester for each test case, and it is used in place of the normal test function. So let me just go back here and we'll take a look at what widget tester is. So widget tester here, this is what is going to be building the this is what is used to build the widgets. So tester dot pump widget, I'm going to instantiate my widget. It's called counter widget. And what I'm going to do here is I'm going to find a text widget, which is right here, which says counter. And obviously, initially it's going to be 0 because I've set the counter value to be 0. So in my UI, it's going to search for this text widget, which is right here, counter 0. And when it finds one widget, it's going to go to the next line. And what it does here is it's going to tap on the elevated button. Again, my elevated button is right here with the text increment. So when I click on this, it's going to increment by 1, increment the counter value by 1. Now, next, what it does is so pump is like a refresh. So it just refreshes the UI. And after that, it's going to again check for a text widget that says counter 1. So again, when it finds one widget, um, that's when we know that the our test has passed. So let's check, let's just try to run this test. Now we have widget test, counter widget test. So we have our test, the test has successfully passed. So this is what is good. The tester um object is what we're going to build up the UI here. So what we're going to do is we're going to navigate to the counter widget. We're going to look for a text widget, which will be counter colon 0. So when the UI is built, that this is exactly what it's going to look for. When it finds counter 0, it's going to search for an elevated button. When we click on the button, so tester.pump, when we click on this button, it's next going to look for the text widget counter colon 1. So when it finds counter colon 1, that's when we know that the test has passed. So let's again edit. Let's just modify this scenario. Let's say initially my count was 1 and I am expecting a value 2 when the button was pressed. Now this test is going to fail because counter colon 1 can never be true because the value of counter is always going to begin with 0. So this test has to fail, and when it fails, it tells us why it failed. So it says that 0 widgets with the text counter 1 uh, was it was not found because counter always started from 0. So there was no counter is to 1 when the widget started. So that was why we got an error. But if I change this value to 1, if I make counter value 1, and if I rerun the test, then our test is going to pass because the the app started with counter 1 value. So when the UI was built, counter 1 was found, this text widget. And when I incremented, when the button was pressed, counter 2 was found. So this is how we can test the widgets in Flutter. And this is a very, for convenience sake, for just for today's session, I picked up a very simple example. But you can also explore with much more uh, complicated uh, examples within widgets, and it's going to take a lot of practice to learn the testing here. So yeah, that was all about widget testing. Let's go back to our presentation. So widget tester, as we saw, was responsible for building and interacting with the widgets, that is the text widget with the elevated button and the elevated button with the text widget. Widget tester was the one responsible for it. And test widgets function automatically creates a new widget tester for each and every test case. So this is the one that we're talking about. Test widgets will automatically create a widget tester every time we write a new test widget function. So, and finder classes will allow searching for widgets in the test environment. And this is finder class is the one that we used here to search or to look for the text widget and to look for the elevated button. Again, after the button was clicked, again we looked for the text widget with the counter value 2. So finder is the one that is responsible to look for widgets in a widget tree. And the widget specific matcher is helps to verify whether a finder locates a widget or multiple widgets in the test environment. So that was about widget testing. We have a last type of testing called as integration test. Now, integration test is a complex kind of testing here compared to unit and widget testing, because in integration testing, we're testing the complete app or a large portion of the app, like multiple widgets. If the testing involves a single widget, it is widget testing, where we use the test widgets function. But for integration testing, it is going to be multiple widgets. And this is to ensure that the widgets communicate, the connection that we have built during development between the widgets is well maintained and works as expected. Also, integration tests are used to verify your app's performance. So, obviously, if the entire, if the complete app tested, um, it was tested successfully, that means the app runs as per our expectations. So, it is definitely going to improve the app's performance. So let's look at an example of integration testing. So I have a Dart file here that has two stateless widgets. One is first screen and one is second screen. So let me go ahead and call this from my app and rebuild. So what happens here is it's two simple widgets which say welcome to Flutter. The first widget says welcome to Flutter and has an elevated button. And when I click on this button, it navigates me to the second screen, which is a second widget. So here I have two widgets, and I want to ensure that the navigation here works perfectly. So we are going to write a test that ensures that the navigation from first screen to second screen is working smoothly. Second screen does not have any buttons, it just has a back button, and we go back to the first screen. So let's see how we can write the test for this. Again, we're going to be using the test widgets, which is going to come with Widget Tester that is used to render the UI during testing. So my description here is integration test routing. It can be changed as per the convenience. So let's build our app using pump widget function. Now I'm going to build my app, which is the starting point of my application. And from here, what happens is when my app, when the project is rebuilt, it's going to look for the text welcome to Flutter, the same thing which we saw earlier in integration testing. When it finds welcome to Flutter, finds one widget, then what we're going to do is we're going to tap the elevated button. And when I tap the elevated button, it's going to look for the text. This is the second screen. Now, when it finds this is the second screen in the UI, that's when we know that the test has successfully passed. Now, let's say for some reason I'm writing the code for this is the third screen, but I am expecting it to navigate from first to second screen. And let's see what happens when we run this test. It's going to fail because this is a third screen was never found in the second screen. So let me change this back to second. And now when I run this test, it's going to pass. Now, if you have a question saying, what if I have the same text in some other widget? So one thing that we need to remember here is the navigation from first screen to second screen happens only one time the elevated button is going to be pressed. So if we have the same text in the third screen, the test is still going to fail because we are never going to reach the third screen because you're not pressing the elevated button twice. We're only pressing it once. So what happens is when it finds welcome to Flutter, press the button and immediately look for this is the second screen. And if there is no text uh, like this is the second screen, then again it's going to fail. So here, if I say this is the third screen in my widget, my test is going to fail because it's never going to find this is the second screen. What it comes to is this is the third screen. So this is how you can perform testing between the widgets. For simplicity, I have used here elevated buttons, but you can experiment with the multiple types of widgets. And yeah, let me just change this back. And the test is now going to pass because this is the second screen was found here. So let's go back to the slideshow. So that is how we can perform the integration testing. And here I have only navigated between two screens, but we can use the similar scenario to build more and more complex test cases. And hopefully in the coming sessions, we can write more complex test cases and also test between multiple widgets and not just two. And this is how you can test, this is also how you can test the complete app and improve the app's performance. So, um, yeah, so that's all for today. And I hope you will give testing a read, because even if you are a beginner or even an intermediate programmer, testing is always important. Smaller apps or large scale applications, it's always a good practice to write test cases, because that is how we can improve the performance of an application. So, thank you, and hopefully, we can have uh, more conversation in the next sessions. So, if you have any questions, you can drop them in the comment section. And these are my socials. If you want to reach out to me regarding testing or any topic in Flutter, you can feel free to reach out to me, and I will try my best to help you. Thank you.